Hello and good morning to you all. In the today's class, we are going to discuss about the wrapper classes. So wrapper classes are the classes that Java supports to wrap up the basic data types. The basic data types, as we have already discussed, are integer, float, double, long, and corresponding to all these basic data types, Java provides inbuilt classes. For instance, corresponding to int, the class that is there is integer in full with I capital. So over here, I have shown you the name of the wrapper classes in bold. So double is the wrapper class. Similarly, float, long, integer, short, byte, character, and boolean are the other wrapper classes. The main benefit of these classes is to wrap up the fundamental data types in an object. And what advantage we will get from these? One I have mentioned over here. If you want to pass a fundamental data type to a method by reference, so you have, for that case, you have to use the wrapper class. If the primitive data types are used as a parameters in function, then the primitive data types are passed by values only. So that case, we know that in case of pass by value, if the values of the dummy parameters are changed, then the corresponding actual parameters are not affected. So I would like to remind you the actual parameters are the parameters which are used in the function or method call, and the dummy parameters are the parameters that are used in the function body. So when you change the dummy parameter and the corresponding actual parameters are not affected in case of call by value. So if you want that the value of the actual parameter should change if we do any kind of arithmetic operation or manipulation on the corresponding dummy parameter, so then we have to use the wrapper classes. So these are the inbuilt classes, and these are available in the lang package. So you need not have to import any package for the use of these classes. So the first wrapper class is the character class. So as we discussed earlier, it is this class can wrap up the fundamental data type character. This class provides a constructor to which you will pass a character, and that character, from that character the object will be constructed, and that character will be stored by the object as a instance variable. So how we can use it, that we will discuss through the program. So one of the methods that this class provide is character value. So if you want to recover the character value, then you have to call the char value method. So I am going to show you the example for this, how you can use it. For that, we are going to create a package over here, and we will implement all the wrapper class examples in this package. So I'm going to name it a wrapper, and this is our first example on the wrapper class. So I'm going to name the class as wrapper1. In here, I have, let's say, one character type variable, and value is let's suppose a, and I want to create an object corresponding to this character variable. So for that I have to use wrapper class, and the wrapper class name is character. Here I'm going to create the object ob, and as we know that if you want to create the object, you have to use the new and then the name of the class. So when this object will be created, constructor will get called, as I have shown you earlier on the slide, that the character wrapper class provides one constructor that receives a character type value, and from that value it builds the object. So here on the right hand side, the parameterized constructor of the constructor character class will get called. The object corresponding to that will be created, and that object will be referred by the OP. So this is called the wrapping of the fundamental data type. We have fundamental data type ch. We have wrapped it in the form of a character type object. So that character object will contain the value of the variable ch, that is a. So if you want to retrieve that character value back in some other variable, then I can use this statement like c is equal to ob dot char value. This I showed you on the slide as well. So if you want to retrieve the value or fetch the value from the object, then you can use the char value method. Call the char value method of the character wrapper class. So you will get in C what is there in the object OB. So in object OB the value will be small a. So if you try to print this C, you will get uh, a as a result on your monitor screen. I'm going to show you that. Uh, I'm going to print C over here. So when you will print C, you should get the value A on the screen. So see here we are getting the result A. So we here what we did is I'm going to repeat that. First we created the object from a fundamental data type char. Then from that object we retrieve the value. And one more operation is possible on this. So if you want to create an object from a fundamental data type, you can use this statement also. I'm going to show you that also. Here is another object that I'm going to create. The data type is char, the object name is ob1, and I'm assigning a value directly to this. So this is also possible. If you assign a primitive data type character to a character type object, the Java will automatically build the object out of that. So here on the right hand side, the constructor will get called automatically. A character type object will be created, and that object will be referred by the variable ob1 or the reference variable ob1. So this is called auto boxing. Auto boxing is basically the process of conversion a fundamental data type to its equivalent object type. So if the fundamental data type is character, the object that will be created from this will be object of the wrapper class character. So here the auto boxing is being performed by the Java. So similarly, auto unboxing is also possible. So auto unboxing is conversion from the object to its equivalent fundamental type. So if I let's say assign the value of this object ob1 to a fundamental data type. Let's say t is the variable, fundamental variable. If I assign ob1 to t, the here at this step auto unboxing will be performed, and in case of auto unboxing, uh, object of type character will get converted into fundamental data type character. So this is called auto unboxing. So later on, if you want to print the value of t, you can print it to verify this. So I'm going to do that over here. So I'm going to use print t. So this will give you the value of t. See here, we are getting the result t in this case. So in this program, we are basically wrapping up the character type, fundamental character type into the character object, and then we are retrieving the value of the character from the character object using char value, or you can retrieve the value uh, from the fundamental from the object by auto unboxing. So this is also possible. So let's go to the next concept on this wrapper classes. So this is what we discussed earlier. The char value method is there. Then the next wrapper class is Boolean. This is corresponding to the fundamental Boolean data type. So please notice that only one letter change is there. Fundamental data type Boolean having b small, and the corresponding wrapper class has b capital. So I would like to remind you that Java uses the Pascal notation for naming the classes, and in case of Pascal notation, every word will have first letter capital. So here only one word is there, Boolean, so it has first letter capital. Uh, and in case of fundamental data type, the Boolean b is small, right? So this class has two constructors, as I have mentioned over here. One is you can pass it the Boolean value and build the object out of that. And second is you can pass the string value. So if a string is having true in double quotes, then from that the object will be built, or the type should be Boolean. If you want to retrieve the value from the object, again you can use the method Boolean value. So in case of character, the method is char value. In case of Boolean, the method is Boolean value. So let me show you the example, simple example of this as well. So for this, we are going to create another program, and we are going to name it wrapper2, and here is the name of the program, wrapper2, right? I'm going to copy the previous program over here to save time, and here I'm going to rename it as wrapper2. So now what I want to do is I want to create a Boolean object. A Boolean object name is, let's say, ob1, and from it to store in it, we are going to first build uh, object explicitly using the new. So I'm going to pass the Boolean value to it, to this constructor, and from this the object will be created, and that object will be referred by the ob1 object. So if you print the ob1 object directly, and then the auto boxing will happen automatically, and here first what will happen in this case is, if you print the ob1 object directly, the first point is toString method of ob1 will get called, and uh, that will give you the string equivalent of the value contained in it. So it will return false, and that will get printed. Another method can also be used as we discussed earlier in case of auto boxing or auto unboxing. Here we have OB2 and we are going to pass it another value. So it's right, but this is not doing it because if in case of auto boxing the value should be the Boolean type. So here this will perform the auto boxing operation, and later on if you want to get the value back, again you can do that using by calling the function. So Boolean type variable is b, let's say, and in this I want to retrieve the value of ob2 object by calling the method Boolean value. So this will give you the Boolean value of the object, and then we want to print it using this line system.out.println. I'm going to copy it to save time. So here I will replace this OB1 by OB. So I'm going to print the value of B using this statement. So see here we are getting true in this case. So you can pass this string as well. So I'm going to change this line. If you pass the string again, the object will be built out of that, or you can pass it even capital false. Let's check that also. If I pass it capital false, again it is building. So in case of string, you can use capital letters or lowercase letters, and the Boolean object will be built out of that. So if I just keep the F capital, let's see what will happen. Again, it is building the object. So in case of Boolean data type, if you want to build a Boolean object from a string that is representing a value true or false, irrespective of the case, then this can be used. Now let's move on to the next slide. Corresponding to the numeric data types, we have wrapper classes, short, byte, integer, long, float, and wrapper. And please note that this for number wrapper classes inherit the abstract class number, right? And abstract class number has some methods. These are the methods that are defined in the number class. These are byte value. If the object is of byte type, then you will use this byte value to retrieve its value. If the object is of wrapper class double, then you can use the double value to retrieve its value, and so on. So depending upon the type of the object, you can use the corresponding method to retrieve the fundamental data type from the object. Or you can say that you can unwrap the fundamental data type using these methods. So here is the slide on integer class. So in case of integer, if you want to build a wrapper class integer object, you can call these two constructors with by numeric value using the first constructor, or from a string that is representing a number using the second constructor. And if you are using the string format, if that string is not representing a valid numeric value, then it will throw number format exception. And if that is a valid number, then the integer type object will be built out of that. So all the numeric wrapper classes overrides the toString class. So whenever you will try to print the object of the wrapper class directly, this method will get called, and you will get the corresponding string representation of the value contained in the wrapper class object. So I would like to show you some examples, more examples on that. So here I have some slides. On these slides I have pasted some of the examples. So let's discuss those examples first. So in this example we are building the integer wrapper class object. So this is the case of boxing. So this is called boxing when you wrap up a fundamental data type in an object corresponding a wrapper class object. So when it is happening automatically, then it is called auto boxing. As we discussed earlier, if you assign an integer value to the integer object, then in that case the object will be built automatically, then that is called auto boxing. Or if you are explicitly creating the object by calling the constructor of the wrapper class, then that is called boxing. So here we are performing the task boxing. So this will create the object, and that object will be referred by the IOB object. Then you can retrieve the value from the object as we discussed earlier using the method int value. This will give you the fundamental or return the fundamental type that we will store in the left hand side variable I, and later on you can print that value I directly as we have done in this example, or you can print the object directly. If you print the object directly, again the auto unboxing will happen. In this case this object will get converted into fundamental data type, so you will get the corresponding value 100 from that, and then that will get printed, right? So this is what will happen over here. This we have already discussed, auto boxing. So this is the example as I have shown over here. If you assign an integer value directly to an object of type integer or reference of type integer, then this integer value 100 will be automatically get converted into the object, or we can say the object will be created out of this value, and that object will get the reference IOB, and the process that is being performed here by the Java is called the auto boxing operation. So again, I have shown you the example for that. So I'm quickly going to discuss this with you. So in the first line, we are creating the object over here using this line. So here the auto boxing will happen, and then we are assigning the object to fundamental data type. So auto unboxing will happen over here, and then you are printing these two, the fundamental data type and the object. This we discussed in the last slide as well. So this object will get converted into the fundamental data type through unboxing process, and you will get the value of the value that is contained in the object on your monitor screen by this method print. Then some more examples are there. This example shows the benefit of using wrapper classes. So here we are passing an integer to the method through a reference, right? So here what I'm doing is I'm showing the example to you over here. So this in this case, I am calling the method m and passing 100 to it. So if you look at the method, I'm going to draw a boundary around this method. So this m method has one parameter of type integer. So notice that this integer has I capital. So this is a wrapper class basically. So when you will call the m method with the fundamental data type 100, so this 100 we are assigning to v. So auto boxing will happen over here. This 100 will get converted into an object of type integer, and the v will get the reference of it. So I'm going to show it over here. This is the object that will be created with 100 value. 100 is there in it, and this object is being referred by the wrapper class reference v. So so this is the example of the uh, passing the fundamental type to in the method by reference. So in this case, this method is returning v. So because v is now referring to the object of type integer, when you will return it, and we are on the left hand side the reference IOB. So this IOB will get hooked to this object that is already there in the memory, and because the scope of v is limited to this m method only, now this v will not refer to the object when the control will come out of the method, and then we are printing it. So this example is showing us the boxing and boxing operation or auto boxing operation happens when you pass the parameters to the method. If the fundamental, if the actual parameter are of fundamental type and the dummy parameter are of reference type. So here the actual parameter are of fundamental type, but the formal parameter is of reference type. So auto boxing operation will happen over here as well. So here is another example on the wrapper classes. So we are performing a bit different operation over here. We have two integer type objects, IOB and IOB2. Then we have one integer type variable I. We are assigning 100 to IOB. So here auto box the object will be created. Then we are performing over here increment operation on the wrapper object directly. So what will happen in this case is when you perform the operation on the wrapper objects directly, first unboxing will be, so this IOB will get converted into the fundamental data type, that is 100. After that the value will be incremented by 1, so this will change to 101, and again 101 will get converted into the wrapper class object. So first, if you perform the operation on the fundamental data type, first the value, the object will be unboxed, right? Auto unboxing will happen. Increment, after that the increment operation will be performed, and then on the new value the reboxing will happen. Again the fundamental will get converted into the object. So this is the operation. So main important point is you can perform the arithmetic operations on the wrapper classes as well, and if you do so, then the objects are basically get converted into fundamental type through auto unboxing. After that the operation is performed, then again the reboxing operation will happen, and the resultant value of the expression will get converted into the wrapper class object again. So I'm going to show you another example over here. So in this case, we are performing another arithmetic operation. So first of all, IOB, we are dividing it by 3 because the precedence of the expression that is there in the parenthesis is more. So first of all, the expression that is in the parenthesis will be evaluated. So that means from this expression, the expression sub-expression IOB by 3 will be performed. So here in this case, the denominator is of fundamental type, but the numerator of the expression is an object. So because these two are of different type, so Java, what the Java will do, it will automatically unbox IOB. because IOB is of wrapper class integer, so you will get the corresponding primitive type when the auto unboxing will be performed. So here you will get the value of this, that is 101, because we incremented OB at this step. So 101 by 3 you will get some value, and integer value corresponding to that, because this division is the integer, it performs the integer operation. So 101 by 3 you will get 33 from that expression. Then this 33 will get converted into the object again. So you will get the object 33 over here, integer object. Then we are performing the operation on the objects as well, IOB plus IOB. So these two will get converted into the fundamental type. In IOB we have value 101, and the result of this expression is 33. So this will give you 134 primitive data type that will be converted into object through auto boxing, and that will be referred by another object IOB. So this means the IOB2 will have value 134. When you will print it, you will get over here 134. So again here we are printing the IOB directly. So auto uh, unboxing will happen over here. You will get the fundamental data type, and that fundamental data type will be converted into string then, and you will get the result back on the screen. So I'm not going to discuss this because this is the same case. So but the difference in this case is because we are assigning the value to integer variable, so reboxing will not be performed over here. The rest of the operation will be same in this case. So if you have doubt regarding this, you can ask. Otherwise, I am going to leave it to you. So the next class, wrapper class, is again we are using over here the double, right? In case of double, we are assigning a double type value to the double type reference variable. So auto boxing will happen over here, and after that what we are doing, we are adding the double type object and integer type object, because when you add the objects directly, as we discussed earlier, Java automatically perform unboxing. So this will get converted into a double value. This one I'm going to write it on this side. So this will give you the value 98.6, plus this will also get converted into fundamental data type, and this will give you the value 100. Then because one is of type double, other is of type 100 integer, right? Then this will get converted into double, as we know that if the uh, operands of the expression are of different type, then they are converted to the same type by type promotion. So here this will be promoted to integer, will be promoted to double type, and you will get the double result from this expression 198.6. Then we are assigning this 198 to DOB again. So here the auto boxing operation will happen, and this value will get converted into the double type object again. And after that, in the system.out.println, we are printing the DOB object. Again here, the Java will apply the unboxing operation, and you will get the result on the screen. This is what will happen. Again, I have shown you another statement where the unboxing operation is performed. So in this case, we are building the integer type object from the fundamental type. So here auto boxing will happen as we discussed earlier. Then notice that we are using the integer type object in the switch directly. So when you use it in the switch, but the cases are of integer type, so here what will happen, the Java will convert this object IOB into the fundamental data type through unboxing. So this expression will get evaluated to 2, and the second case will be evaluated after that, and you will get 2 on your screen, and with the break the control will come out of the switch. So the crux of this example is that you can use the reference type objects, wrapper class objects in the switch statement also, and whenever you use that in the switch, that will be automatically unboxed to obtain the fundamental data type. And next is example is on Boolean. This we have already discussed, but I'm going to discuss whatever is given in this code. So we are creating a Boolean class object over here from this statement. This I am not going to discuss. Then we are using a Boolean object be in the if directly, because we are using the reference of the wrapper classes over here. So what will happen, because in case of if operates on the fundamental Boolean type, so this be that is reference to the Boolean wrapper class, that will get converted into the fundamental type. So here in case of if, the auto unboxing operation will be performed, because its value is true, so this will be converted to fundamental Boolean true, and because if is true, then this expression will be evaluated and you will get the value B is true on your screen. Then there are some other auto boxing operation. This we have already discussed. I'm not going to discuss this with you again, but this line is performing auto unboxing over here, because ch is the object reference to the object of type character, and you are assigning it to the fundamental variable ch2 of type character. So auto unboxing will happen over here, and in ch2 you will get the value that is contained in the character type object ch, that is x. So you will get the x in this case, and we are printing that value through this line over here. So this is all about the wrapper classes. If you have any doubt regarding any of the wrapper class, you can unmute yourself and ask your doubts. So